Welcome, everyone, to the Genetics Podcast. I'm really excited to be here today with Dr. Maria Chatzou Dunford. Maria is the CEO and co-founder of LifeBit, which is a company based in the UK that provides software for analyzing genomic data in the cloud. The users of the LifeBit platform are, for the most part, genomic scientists at genetics companies, biobanks, as well as pharmaceutical companies. As a quick aside, we have actually used LifeBit here at Cytogenetics for about a year and a half, so I think it's needless to say that we're big fans of Maria and her team's work. So just as a quick backdrop to what we're hoping to cover today, as you all probably know, the amount of genetic data that's being generated through research, through medical care, the healthcare system, and at-home testing services is simply enormous. So for example, a whole genome sequence generates about 100 gigabytes of data. So if you were to take a project like the UK Biobank that's in the process of whole genome sequencing about 500,000 people, this translates to 50 million gigabytes of data, or about 50 petabytes. So the question really that we're going to revolve around today with Maria is how do we actually make sense of this huge amount of data, why it's important to use the cloud, in quotes, to analyze data from an efficiency, cost saving, security, speed perspective, and then hopefully to pick Maria's brain on what some of the most exciting new initiatives in genomics are out there today. So with that slightly long intro, I'd just like to say thanks so much for taking the time to join today, Maria.
Thank you, Patrick, for having me. It's really great to be here.
Great. So just to kick off, I wonder if you could give us a quick overview of what LifeBit is, how you got started, and what people use the platform for today.
Yes, absolutely. So LifeBit is a biotech company, and how it got started basically was by my founder Pablo and myself, from the typical story, being researchers ourselves, having as a main job to analyze and make sense of, as you said, enormous amounts of genomic data. And at that point, which was almost now 8 years ago, most of our time, 80% of our time, was spent on the computational and data hassles around that, rather than the biology and the results and what the insights, if you like, around the data. So with my co-founder, we worked a lot on building solutions that will make it easy to analyze this data and make sense, and not have people spend most of their productive time, dealing with things that are completely unproductive, like computational and data hassles, as I said before. And as I said, we're involved in developing many different open source technologies widely used right now. And as the time was passing, we realized that our problem was not a niche problem, was becoming a problem of the whole world. And that was the point where we decided to jump at LifeBit, because we realized that all of the work that we were doing from a research perspective, and by building all of the open source that we did, was just a tiny bit of all of the technology required to actually, make this problem, solve this problem once and for all. So we started LifeBit, and the mission of LifeBit is from a solution perspective, a dual mission. One, to free the world from the computational and data hassles of making sense of this data. And two, to actually then build the cognitive technology using AI, machine learning, smart algorithms to be able to reason for this data, about this data like humans would, right? So in its final form, our technology will be able, just by being exposed to data, to actually generate actionable insights and reason about it like humans would, right? We don't know intervention ideally from humans. And that's what we're trying to do right now.
Great. That's wonderful. So if we could take maybe one example, I like the dual mission. So the first is to free people from these data hassles. And then the second is, I suppose, to free them from the analysis hassles and allow the analysis, or at least most of it, to happen by itself. I wonder if we could go through an example, whether it's a genome-wide association study or polygenic risk score or something else that you all work on regularly, and talk about what are those data hassles, and maybe some of the machine learning approaches you're taking to help analysis as well.
I like to always see the process of making sense of genomic data as a three-stage process. The first stage is the biochemical, the liquid process, right? We need to extract, samples, and then we need to be able to process these samples, throw them into big sequencing machines or small sequencing machines, since, that's being more and more automated. And then out of that, that first process stops when we are getting, all of these raw data, the sequence data, as we call it, which is like small fragments of read of DNA that really, doesn't, have been multiplied and copied numerous times, right? And doesn't really make sense to anyone out there, right? The second stage and second part of this process is actually what we call the downstream analysis, where your whole mission is to convert now this raw data that has just come out of the machines into a format that would make sense. And what would be such a format? If I give you, the reads, the raw reads as they are coming out of the machines, there is no human being on this planet that can make any sense out of that, right? But if I give you, a list of like mutations that you have on your genome, even my grandmother can understand that. My grandmother most probably cannot do anything with that information because she wouldn't know where to even start, right? But she could at least, with minimal explanation, understand that, like what you are showing to here, is, some coordinates of genes and mutations. And, in our DNA, we have 4 letters and so on and so forth, right? And that's readable. That's readable by humans, right? So the downstream analysis, as a general process, has many different parts and many different types of analysis that we could run. But the overall mission is get this raw data to an informative state, right? And as I said, that informative state being a list of mutation, maybe, your ancestry or, like annotations around genes and so on and so forth. So there is a lot of different things that we are doing at that level, right? And of course, if I am to give some examples of what are the more standards when we think in terms of human genetics, of course, the most standards are what we call, variant calling. So understanding, calling the variants, because between all humans, the difference in DNA are in the level of 0.001%, right? So calling that, small percentage of differences between different individuals and getting this, put it roughly, the list of different mutations or the different variants, as we call it. I think that is the most typical analysis that we run in that process. Sorry, that's I was calling downstream, but that's actually the upstream analysis. And then the downstream analysis is when you have that and now information, and now you are further analyzing it, right? And in downstream analysis is you have a lot of things happening in the downstream analysis, from analysis that try to understand which of these, for example, variants and mutations are linked to cancer, different annotations of genes to see what other, diseases you might be having if we're talking about diseases. If we're talking about biomarker discovery, we're having a lot of different things where we are, trying to understand, like maybe what mutations can be related to different drugs. Going beyond that, when downstream analysis starts becoming more useful and more actionable is when you are doing what we call integrated analysis, right? And integrated analysis means that you are now integrating genomic data with different clinical phenotypic data. And it's normally at that point where also your computational methods need to start becoming more sophisticated, right? And that is normally the point where we include AI and machine learning. And at LifeBit, one of these applications is our AI engine, which one of the algorithms that the machine learning algorithms that the AI engine is basically has learned how drug response work, right? When a cell is exposed to a particular drug, how does it respond? How does the gene expression changes as a response to that drug? And it has learned from different data that are coming to describe that response, right? And so then when you are feeding, some new genetic data from a drug you just screened into a new cell line and you've just measured the gene expression levels of that cell line, then you can feed that into the particular suite of the AI engine for the drug response, and then it will be able to tell you what the drug does, right? And what is the mode of action of the drug? What is the disease that it targets, right? Because it has actually, learned from combining all of the gene expression and gene, in general cell response data with disease data, with mode of actions for drug data, chemical data, and so on and so forth. And those are the analyses that, are at the very far end of downstream and more sophisticated downstream analysis. If I am to give a prediction about the future here, the future of this whole sector is at that far end. Everything else, the first stage of the of the sequencing that is done now by machines is becoming more and more automated, and big companies are taking care of that. The upstream analysis of trying to understand, to convert raw data to informative is becoming more and more standardized with time, especially for human genetics. It's almost standard. And of course, when we go to other species beyond humans, it still needs work, but it will get there. Where we need to be focusing on our efforts, and especially at LifeBit, we know that more than anyone is more at the far end of like, now how can we do integrated analysis where we can bring a lot of data in conjunction with genomic data to actually deliver actionable insights that do reasoning, right? Because if you look at, when a system can tell you what the drug does, so what's the mode of action, what disease does it target, it basically reasons. It does the same job as a group of, 20 drug discovery researchers that will do manually, right? To take the same decision and the same reasoning about what do drugs do.
Absolutely.
I think that was a little bit of a long answer, but
yeah,
hopefully it was explanatory now.
It's great. And I think you're exactly right that there's a huge amount to be done in the interpretation side as we get better at gathering the right data, aggregating it in safe and effective ways, doing the upstream analysis that you mentioned before to go from raw data to something readable, then the magic really happens, right? We only do all of those things so we can find better treatments for diseases, prevent disease before they happen, and do something that ultimately impacts people. Kind of to segue there, I know that you all are involved in a COVID-19 related collaboration with Genomics England. I wonder if we could talk about that a little bit, because this is one of the most top of mind applications of genomics and artificial intelligence, trying to understand why some people respond very severely and other people end up with mild or asymptomatic cases, and whether there's some hint in the data to potential treatments or whether it's antivirals or vaccines or otherwise. Is that something that you all are starting to launch imminently?
Yes, absolutely. I mean, we have already been working with Genomics England. The news have just now hit the public, but we have already been working very closely for over a month right now with a mission to launch the whole system at some point in July. Mid of July is where we are aiming. Now, what is this all about? So as you most probably already have read from the PR releases being out there, the UK government is actually funding a huge program to sequence 35,000 individuals, 20,000 with severe symptoms and 15 with mild symptoms of COVID. All of these data are coming from all of the hospitals across UK. It's an incredible effort. It's the largest and more significant effort right now on this planet. And I cannot but commend the UK government for taking that stand. And that project is officially run and brought to life by Genomics England. And we started the collaboration with Genomics England because Genomics England was looking for an ideal technology partner and a platform that would be providing access and analysis over this data, right? Now, what are the data that we're talking about? As I said before, 35,000 individuals, but we're not just talking about whole genomes here. We're talking about all of the clinical data, as well as potentially different phenotypic data that we're going to be getting from these individuals. Not all of these data are going to be made available at once, but they are going to be coming there. And again, what are the typical analyses that our platform as the new research environment of Genomics England is going to be enabling is exactly analysis around the severity, trying to understand the severity of the disease, especially digging into the genetic factors that can actually that can explain the severity and how it impacts different people. Also understanding the differences between women and men. Most probably you've seen that, men are more susceptible to this, and we're still to understand why is that, if it is environmental factors or if it is genetic factors, right? Potentially, maybe it's a combination of both, right? But even beyond that, I would say COVID, it's a good stepping stone for us to understand infectious diseases as a whole and why are some of the differences. It opens up a big chapter, right? That in the past years, and if I am to make a parenthesis here, in the past years, all of the population genomics effort has been focusing mainly around cancer and rare diseases, and that is also what Genomics England 100,000 genome cohort is composed from. And right now, Genomics England and the UK government is opening a new chapter where it's bringing back the focus to infectious diseases, and is I would say, it's pioneering once more, and it's incredible because Genomics England pioneered, the population genomics when it comes to cancer and diseases, and now it's actually pioneered for infectious diseases, and bringing back the focus to population health, which is very, very important. I think population health has been ignored in the past years. COVID is bringing that to the forefront, and what we are doing there, we are trying to help with all of the different analytics tools and data to understand, as I said before, not just the severity of COVID or the differences between men and women, but also how infectious diseases work and how that impacts population health as a whole, right? And that's what is at stake here.
Amazing. So if I think I understand from the participants' perspective, if they join the Genomics England and Genomic Research Project, which we spoke to the CEO of Genomics England and clinical lead, Chris Wigley and Richard Scott on I think 2 episodes previous to this one. From the participants' perspective, when they join, they'll be agreeing to have their data analyzed in a secure way by any researchers worldwide that are interested in working on therapies related to COVID, assuming that they get the permission of the study team. So will they be able to then access that data through the LifeBit platform? Is it in addition to the Genomics England research environment, which already exists, and you'll be providing another way to access that data? And do you also have access to other sources of data? Because the UK Biobank is doing a very large study, and I think it would be amazing to be able to have, from a research perspective, all of this data in one place in a secure way where people can analyze it without having to go to every single source individually.
Exactly, Patrick. That's exactly what we are enabling for also the first time. So the LifeBit platform technology it's a federated technology as it's called, right? So federated technology, in short terms, what does it mean for our sector and our applications is that data can be processed and analyzed in place, as we call it. So without moving the data, the computation comes to the data. And as such, you can actually combine data from different sources and run joint analysis over these different data without necessarily moving the data. And that is very important for security, and also not beyond security, like moving data, as you said before, is very, very big, right? So you are looking at very big time, transfer times and costs if you are trying to move this data, plus all of the security, regulation, compliance, storage requirement even so, because, okay, I'm moving the data, but where I'm exactly, hosting 50 petabytes. And that's why also UK Biobank and Genomics England, because in UK Biobank, you can actually download the data, right? As long as you become part, you get accepted to do so. You can download them, but where do you put 50 petabytes, right? And, how long do you need to wait to get that, and how much money you are paying, right? So it's not just a matter of security and regulation. It's also a matter of, the technicalities of it. When it comes to Genomics England, of course, that is the big change that we are introducing. We're going to be having a platform, the new, as we are calling the research environment 2.0, or the COVID research environment. It's going to start with the COVID research environment and then evolve to the research environment 2.0. It's going to be running in parallel to the existing research environment. It's not going to be discontinued. The research environment 1. The difference is going to be that this environment is going to be cloud-based. It's going to be hosted over AWS. Again, all of that is in the PR release, but it's going to be on London, if you like, cloud, right? So very localized way of doing cloud, which is required for the security of the data. And what does that mean for our users? That means that they can actually scale any type of analysis as much as they like. We can support any number of users because the idea of this is to be used by everyone in the world. I'm sure Chris, if you had him here, I'm sure Chris has gone in length through that. And, that the mission is to enable anyone out there that wants to be doing research over COVID to do so, right? And not just COVID, because eventually, we're going to be bringing also the data from the 100,000 genome cohort of the cancer and rare data. So anyone to be able to do any research over those. So scalability is something that's going to be enabled by cloud. The second big thing is collaboration. The platform will be offering incredible collaborative functionalities. People will be able to create collaborative workspace, invite all of their collaborators and team and work in this collaborative environment. The third most important thing is flexibility. What do we mean by flexibility? The users is exactly, which will be enabled by the federated technology, will be enabled, first of all, to bring any tool they like, similarly like you do in your smartphones, where you can go to, to Play Store or wherever else, and you can actually install any, or you can bring
to an app store.
Yeah, exactly. And they are going to be able to bring any tool that they would like into the platform and run it transparently. And it's going to be in a federated manner where actually private tools or tools coming from private repositories, their codes are never being exposed into even us at LifeBit that have the platform cannot actually see it, and no one else is going to be running in a federated manner. But then the most important thing, as you just said, they are going to be able to also bring their own data and mix and match publicly available data, their own private data with the Genomics England data without actually any movements of data. And then the computation will be able to happen jointly over this data.
That's fascinating. So who are the primary users of the platform? Would it be a scientist at a pharmaceutical company that's trying to understand if their molecule can help? Is it researchers at academics, universities, nonprofits? Is it all of the above? What is the mix of people that you all work with look like?
The way I like to think about it, or the way we're thinking about it at LifeBit, is we have 3 distinct use cases that we are serving right now. And those 3 distinct use cases correspond obviously to different stakeholders or different users. The first big use case is drug discovery. The environment is trying to enable drug discovery. The biggest goal, hands down, from everyone on this planet is to try to find vaccines and treatments as soon as possible. And not just for COVID, as I said before, even beyond COVID, right? For the next, COVID that will happen in this world, to be ready for it, to know how to even have ready, potential data that could help us on that development, tools, methodologies, platforms, ways of working, right? And that's what we're establishing here. And that's why Genomics England is pioneering this for the first time in infectious diseases, and once more for the universe, on how this should be actually happening. So drug discovery. And when it comes to drug discovery, the users is very simple. What users need to be doing is they need to be able to bring their own data, combine it with the data of the COVID, run joint analysis. Drug discovery also, they do have very specialized tools. So, and we're talking now here about the big pharma, the big biotech companies. They will have specialized tools that they will also need to be bringing in the platform. So that's why it's very important for us to enable them to do these things, right? Then the second use case is diagnostics. And diagnostics most probably in the biggest, I would say, in a broader term of research, because we're going to be having clinicians coming to the platform, trying to understand the differences, as you said, in severity, in the patients, the patient profiles. They will try to understand even in terms of symptoms, how does this patient look like? And that will help for future diagnosis. What is important to those users is much more, those users, they do not normally have their own tools or their own data they would like to bring as a whole. Of course, there are exceptions into that. But what they do tend to have, or they need, is quite a lot of publicly available data, quite a lot of publicly available tools that they are used to using, annotations from different datasets, and they want to be pulling all of that very easily together in a way that is straightforward, that they don't need to be doing that much of computation, right? And they are very much used to looking at data on an individual basis. So it's also very important for them to be able to have, in a singular view, a lot of complex data presented in a way that's very readable. So it's a big challenge for us to enable that. And the third use case is research, is pure research for the sake of understanding, as I said before, how can we, for understanding how COVID disease works, how the virus manifests, or how the disease manifests, how the virus works within an individual, how the disease evolves, right? Again, for these users, very similar to the previous use case, they need a mix of both. They need to be able like the drug discovery people, they will have their own specialized tool, their own specialized data. They will need to be bringing that to the platform. Similarly to clinicians, they will need to have very complex oversight, very complex views or simple views of very complex data, at a glance, so they can actually start developing hypotheses, which then they can actually test in a more sophisticated way, by running, more, data science analysis or bioinformatics analysis, if you like. So those are the three use cases that we're currently serving.
Where in all of this does the data itself actually sit? Can it be on a personal computer, on an Amazon Web Services cluster, Microsoft, Google, some server, an old company server somewhere? Does it not matter to you all where the data sits and you somehow plug into it? Or does the data have to be on one of the big cloud providers like Amazon or Google or someone else?
That's a great question. So for just again, for avoidance of any doubt here, the Genomics England data, they are hosted on London-based servers provided by AWS, but it's a joint thing with Genomics England. So, and these data are securely there. They are never going to be leaving that location, and they are accessible through the cloud, through the AWS cloud, through the platform, right? You cannot access them barely through the cloud. You need to go through the platform, through the AWS to get them. Now, the user data, of course, they can be anywhere. Now, being anywhere, does it mean that by being anywhere, is it accessible anywhere? Not really, or not at the same level of easy access. The best way is for the data, obviously, to be on AWS S3 buckets, because then it can be very easily linked into the platform and imported. They could be on any other cloud as well. We are going to be enabling that as well. Now, if they are somewhere on a local computer or a local storage, it's very difficult to access through internet. And as such, they can again be brought into the platform, but in that case, actually transfer of the data has to happen. So physical upload of the data into the platform has to happen, right? Because it's impossible to be accessed in any other way. So can the data also be in some public location on the cloud and fetched like that? Not necessarily through cloud, yes. And that's another thing that we are enabling into the platform very easily to happen. Again, though, if the data is in someone's laptop or in local storage, then they have to either be made available publicly on the internet, for example, in sequencer, publicly available in public available repository like the SIG-Array, or Sequence Read Archive, or in some server that is made publicly available, or they have to be put in the cloud and ideally into an AWS S3 bucket. So the users will need to have an AWS account to do that. Otherwise, the other choice is, of course, going with traditional upload. You log in into the platform, you can actually then bring data from your laptop.
That makes sense. So what does the future look like for you all? Do you imagine a world where every individual has access to all of their genomic, medical, other information? Do you think some of it will still live in other parts of the healthcare ecosystem like it does today in the electronic health records and other places? And do you imagine that LifeBit will kind of connect all, wherever they live, all these pieces of data together and then enable you to build a kind of interpretation engine or brain that can make sense of all of that data? Or do you see it somehow differently?
That's exactly the plan. I mean, we're working with Genomics England, we're working with other pharmaceutical and research clients, and everyone wants this world, right? Like the data by itself can be very valuable, but all of the data put together can be infinitely valuable, right? So it's better when shared, right? Yeah, better. The value grows exponentially when data are being combined, and there are even publications showing this. On particular, when you run GWAS analysis, on 100 times more data, or what happens, and so on and so forth. So we've shown that it's nothing that we are coming here as LifeBit and we're saying, here are some news to everyone, right? Everyone knows it. It's more of a matter, how can we make that a reality? LifeBit is, if not the only company, definitely among the first companies and very few out there making this a reality right now. And working with Genomics England is the biggest testament and proof that we can do this. Moving beyond that, of course, I think even Genomics England welcomes a world where we could potentially, for example, even working with UK Biobank, we could actually unify this data. I don't see why, UK Biobank, we cannot work with UK Biobank, put our platform there, and then we're actually creating a tunnel system, right? Where it's very easily, you have a federated system right now of platforms on both ends where they can users on both ends could actually, benefit from the data without the data moving. I think across UK, it's an excellent opportunity to do this. We don't need to go to the hospital levels. We can already stay at the biobank level and population genomics. Anyhow, most of the medical records are already there. At LifeBit, we are ingesting and we're making available through the platform through excellent cohort browser and biobank data browser functionalities, all of the, clinical record data coming from both primary and secondary healthcare, right? And why I'm saying that not hospitals yet, because hospitals do not yet have enough genomic data. And when they do, the genomic data are being anyhow processed and managed somewhere differently, right? At most probably a biobank level, right? So it's better to start from there, make it happen there, make it work there. And then once that's ready, I think it's very easily replicable to the NHS. If assuming, I'm just taking UK as an example here, where then through the NHS, you can roll that out into the NHS. Anyhow, especially Genomics England is interconnected with the NHS, is interconnected, with the genomic medicine system that is starting to come to life, right, as of 2019. So it's a very easy transition, but we need to start from somewhere. And I do believe that population genomics projects is where we need to be, and biobanks is where we need to be starting, and we need to be interconnecting those, and especially at the population level. And I think there should be a directive from the government to do it, because when government steps in and says, because at the end of the day, when government steps in, just to finish my previous sentence, when government steps in, things move much, much faster. And we can see that from the COVID effort, right? But also, it is government's responsibility and it's taxpayer money that paid for the Genomics England data, for the COVID data right now, and for the UK Biobank data. So, of course, the government has a say and should have a say on a simple thing. It's like we need to unite somehow this data. Because if we do, then we're going to be able to speed up research and discoveries at a level that we weren't capable before, right? And LifeBit can do it. We are, ready to go whenever we are required to.
That's great. It's a really interesting perspective. I guess the ultimate aim, at least in the UK, with the healthcare system here, is to deliver genomic medicine or better healthcare to everyone. This includes prevention. It includes diagnoses for rare disease and cancer. And ultimately, this depends on having incredibly high quality data and systems to analyze the data to get those results accurately and quickly. And so I think you're right that it needs to, we need to figure out a way to break these data silos, and it's not by moving them all into one place. It's by figuring out clever ways to connect them.
I think, we used to think in terms of and that was a lot of also first generation platforms and technologies that, are still being sold into the market, and, much to my surprise with quite a big success still. And all of that archetype technology was just built on the assumption that we can move data to where the technology and the compute and the platforms live, and even to vendors, which for me is just it seems so weird. I don't see a world where that can happen. I just simply don't see a world where that can happen. I think, vendors, technologies, compute needs to move to where the data lives, right? And that's definitely a big challenge. Another big challenge, as you were saying, as we're moving more to the NHS and to the healthcare system, and that's what we are also seeing, and we have really good experience in addressing it, is how do you actually transform your data, your clinical and your phenotypic data? How do you ingest them into a system where it can be interconnected with genomic data? And now how can you use that clinical and phenotypic information in conjunction with genetic information to do one simple task? Just identify the subset of individuals for which you want to be looking closer, right? And even up until today, we're not very good at doing it. There aren't almost any technologies out there, again, to the best of my knowledge, that can do that, right? And it's a major thing. And even for LifeBit, we do have the technology and we are doing it, is not so straightforward, right? Because the data that we're coming, especially when we're coming from the clinical data, they normally come in many different formats. In a lot of these data, there are missing data. You have multiple entries for the data, multiple descriptions for the data, and similarly so it's almost like the contrary for the genetic data, because when the genetic data come to us, they are what we call like very orphan, like very, just like get, after obviously having converted them into a readable format, just a list of mutations basically, or all of the variants for the individuals. And then that's it. There is no descriptions around it. There is nothing around it, right? So it's really interesting that on the one hand, we need to be working with the genetic data to bring annotations, bring descriptions, make them usable, make them even more informative. And on the clinical side, we need to be working with like a tsunami of many different types of data and many different information, and just like try to distill that into something, that, it's easily to navigate and understand, right? So the challenge is quite interesting, I would say.
Yeah, absolutely. And I think, but it needs to be done, right? Otherwise, as you say, these legacy solutions where the data gets moved around, it's incredibly costly and time consuming, and it just won't work forever, right? It's only a temporary solution. Well, listen, thanks, Maria. I think we've covered a lot of ground in the conversation. I just thought before we finish up, I'd give you a chance to shout out anything that would be helpful for you right now. I know you all are growing the company and hiring, and probably also looking for other partners who want to work with you all.
Yes, absolutely. So, as always, we are more than happy to work with people that have similar problems to Genomics England and beyond that, and come in and see how our technology could be of use, obviously, and LifeBit as a team could add value. Now, beyond that, indeed, we just closed our Series A round, so we have a lot of money in the bank, just sitting, and we are hiring, we're expanding the team, we're looking for, as Steve Jobs would say, the crazy ones to come on board, people that have pioneered open source technologies, that have worked with complex data, that have innovative ideas, that, as I said, the crazy ones, the people that will bring a new perspective, that will not be afraid to turn the impossible to possible, right? Live in a world where, everything is impossible, and then, somehow they are doing it. I think this is the type of people that we're looking, and we're obviously hiring across all different positions: bioinformaticians, machine learning engineers, data scientists, full stack engineers, cloud engineers, but also on the client side and the business side, we're looking for incredible people for, client support, business development as well. So yeah.
Wonderful. So if you are a self-described crazy one in genomics, bioinformatics, drug discovery, business, then you can get in touch with Maria. I think on Twitter, you're at Maria Chatzou, Maria Chatzou. I'd just like to say thanks, and thank you for taking the time, and we'll catch up with you soon.
Thank you. Thank you, Patrick.